Welcome back. During this video, we're going to look at the right rectangle area model, which will actually give us lower sums this time around. So I have my exact same graph from last time. If you remember, that was the function of 16 minus x squared. Okay, and we're going to look again from 1 to 3, and we're going to look for lower sums. And in order to do lower sums, we're going to have to use a right rectangle area model. We're going to do, again, 6 rectangles. If you notice, I have the exact same rectangles I had before, but these are not right rectangles, they're left. So I'm going to lower each one of these guys until the right endpoint hits. Okay, so I'm drawing right rectangles. Notice the right side of the rectangle is what touches the curve. Okay, the 6th rectangle is kind of arbitrary, or maybe arbitrary is not the right word, I'm not an English teacher, in the fact that it doesn't exist. Right, it has no height, which means it has no area in it as well. Okay, so this is what we're looking at, 6 rectangles here. Now for this particular case, when we're talking about the height of the rectangle, look at the numbers we're plugging in now. We're not starting at 1 like we were before. We're starting at x equaling 1.5, and then 2, 2.5, 3, 3.5, and ultimately 4. Okay, so my height, 1.5 are my x values, 2, 2.5, 3, 3.5, and 4. In other words, it's f of 1, right, my starting point, plus a rectangle's width over and over again. So when I is 1, when I'm talking rectangle number 1, 1 plus a half, boom, f of 1.5. Rectangle 2, f plus 2 halves, boom, height's 2. Rectangle 3, 1 plus 3 halves, right? 3 halves is 1.5, so that's 2.5, boom, 2.5. Rectangle 4, 5, and rectangle 6, again, is the guy that really is pointless. But 6 rectangles, he's there, we're using them. All right, and of course, our width, our delta x has not changed. It's still a span of 3, right? 4 minus 1 is 6 rectangles. Gives us a width of 1/2. So we're going to jump right into sigma notation since we've already talked about how LRAM is used with sigma notation. We're going to say our area, it's our width times our height. And our height, we're going to use sigma notation to represent. The height we already said is modeled by f of 1 plus 1/2 I. Remember, sigma notation says I'm going to add up all the values of this when I plug in 1, 2, 3, 4, 5, and ultimately 6. Okay, accounting for the 6 rectangles. So first things first, let's plug in f of 1 plus 1/2 I into our function. So sigma I going from 1 to 6, and we get 16 minus, instead of x, I'm plugging in 1 plus 1/2 I. So 16 minus my new x squared. So we get 1/2. Sum, I going from 1 to 6. 16 minus, now let's square it, we get 1 plus I plus 1/4 I squared. Okay, and simplify from here, 1/2. Sum, I going from 1 to 6. 16 minus 1 is 15, minus I, minus 1/4 I squared. Whoops, jumped down way too far there. And look at all that disappearing act there. It's like a magic show. Let's bring it back. Magic, 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 magic. The magic man. All right, so now we're going to use our rules of sigma notation. Okay, we talked about the rule for I and I squared. Let's look at the rule for constants. Right, if you're going to add up I going from 1 to some n value of a constant, think about it. If you're doing 5 plus 5 plus 5 10 times, that's just 5 times 10. So if I'm doing c plus c plus c n times, that's c times n. So here's a constant. So I have 1/2. Rule of sigma says this is going to be 15 times 6. Minus our integers, remember, n times n plus 1 over 2. Minus 1/4. Our rule for squares, 6 times 7 times 13, n times n plus 1 times 2n plus 1 all over 6. All right, so let's start simplifying. We have 1/2. 6 times 15 is 90. 42 over 2 is 21. 6 is cross out here. I end up with 91 over 4. Let's take halves, I guess, or no, let's combine like terms here first. 1/2. 90 minus 21 is 69, minus 91 over 4. Yeah, I guess we'll keep working on the inside here. 91 over 4 is what? 22 3/4. 22 3/4. So I have a half of, if I subtract these guys, I get 46 1/4. If I'm not mistaken, that's 68, yep, 69. So 46 1/4 cut in half is what? 23 1/8. And that is our lower sums. And that was using RRAM. If you recall, our last answer was like 43 5/8 or something, which is clearly much larger than this. I'm going to look up here and kind of go over why this is a lower sum, right? We're missing all of this area under the curve here still. I think you guys understood this. I did not mention it this time through, as I did with my upper sum. So let's throw that beautiful, lovely little shading in there. Okay, and that is all the area that we are not accounting for with 6 rectangles. Naturally, if I do more rectangles, the less space I'll be missing, so the better approximation. So there you have it. That is our RRAM, which in this particular case was synonymous with lower sums. Have a good one.